prior to Georg Cantor, the actual infinite was often considered taboo. To quote Rudiger Thiele in Mathematics and the Divine on page 528, quote, Aristotle, René Descartes, Pascal, and Carl Gauss, just to mention a few names, had rejected the actual or complete infinite as unknowable and avoided its application like the devil avoids holy water, unquote. Dobbin echoes this view on page 120 of his book. And on page 121, it is Aristotle who Cantor blames above all else for the opposition to the actual infinite throughout the ages. Cantor felt that the conceptions one applies to the finite should not be assumed to hold true for the infinite necessarily. And it was Aristotle's big mistake to think that same logic applies to both. More on this later. Cantor belongs not to an Aristotelian school of thought, but rather to a Pythagorean, Platonic, and Neoplatonic school. And according to Thiele, Cantor is closer to Leibniz and Bolzano. Spinoza also has a very special place in Cantor's philosophy, as a paper by Dr. Ann Newstead goes into much more detail about. Dr. Newstead also brings up the importance of Cantor's belief in some form of the principle of plentitude. This is summed up as what is possible is actual, or what is consistent with the real is also real. It's the principle of Parmenides when he said that what can be is. Dr. Newstead is right, I feel, as Cantor wrote when justifying how he was introducing new mathematical concepts into the world of mathematics. To quote Cantor, quote, "We may regard the whole numbers as actual insofar as they, on the grounds of definitions, take a perfectly determined place in our understanding, are clearly distinguished from all other constituents of our thought, stand in a definite relations to them, and thus modify in a definite way the substance of our mind," unquote. That's from Contributions on page 67. Mathematics and abstract thought to Cantor are both free, so long as its well-defined notions were consistent with the whole rest of the universe of our thoughts, and free from contradiction. I have to put an asterisk on that because we're going to have to talk about contradictions in more detail later. Cantor's definition of a set as an object of our thoughts or intuition is quite different from what we might hear today in an English-speaking mathematical circle. And still, an even earlier definition Cantor gives of a set is even more philosophical in nature. I am referring to Cantor's contributions to foundations of a general theory of manifolds, usually just called the Grundlagen. This earlier definition is not only associated with Plato's formal idea, or eidos. This work includes a reference to one of Plato's last dialogues, written when Plato was in his 70s, and represents Plato's mature philosophy. I am speaking of the Philebus. This is the same dialogue which speaks of a divine method of dialectic by which the human mind can, quote, discover the existence of permanent, unchanging, real objects, a method perhaps intended to be the reverse counterpart of the divine method of creation by which the system of Platonic forms is originally composed, unquote. That's quoting Dr. W.M. Priestley. In the June 2010 edition of the Review of Metaphysics, issue 252, the esteemed scholar Professor Kai Hauser of Berlin presented a paper which is freely available online called Cantor's Concept of Set in Light of Plato's Philebus, centered around this older Platonic definition of Cantor's. Quoting Dr. Hauser, here, however, we shall focus on an earlier definition that intimates concerns about the ontological status of collections. It appeared in Cantor's Grundlagen einer allgemeinen Mannigfaltigkeitslehre, which summed up the quintessence of his deepest contribution to mathematics, the transfinite numbers, both from a mathematical and philosophical point of view. In an endnote, Cantor emphasizes that Mannigfaltigkeitslehre theory is to be understood in a much more encompassing sense than the theory of sets of numbers and sets of points he had been developing up to that stage. For by a manifold or set, I understand in general every many which may be thought of as a one, i.e. every totality of determinate elements that can be united by a law into a whole. He then goes on to explicate this further by drawing upon Plato's Philebus. And with this I believe to define something related to the Platonic eidos or idea, as well as that which Plato in his dialogue Philebus, or the Supreme Good, calls ekton. He contraposits this against the apeiron, i.e. the unlimited indeterminate, which I call inauthentic infinite, as well as against the peros, i.e. the limit, and he declares the ekton an orderly mixture of the latter two. That these two notions are of Pythagorean origin is indicated by Plato himself. Pythagoras, like Plato, was said to have traveled to Egypt to learn the Egyptian mystery schools of Thoth. Pythagoras traveled to the ancient world in search of knowledge, and is even said to have traveled to India, and it's possible he took back some of the ideas from India, such as the Pythagorean theorem. But he most likely introduced the West to many Hindu ideas. Of course, all of these events are blurred by history. The Grundlagen, which Cantor's Platonic definition above appears in, is in Dr. Hauser's eyes Cantor's highest moment. And it is at the same time that Cantor is at his most philosophical. I now want to quote Godehard Link in the introduction to a great work he edited called 100 Years of Russell's Paradox. You can get this book on GaryGeck.com in the book section. Quote, mainstream mathematicians did not only care little about philosophy, but considered even Cantor, who was really one of them, as too philosophical to be taken seriously. It is a telling historical detail that Felix Klein's widely read lectures on the development of mathematics in the 19th century mentions Cantor only in passing. Bertrand Russell clearly expressed the state of affairs in My Philosophical Development, where he says, quote, the division of universities into faculties is, I suppose, necessary, but it has had some very unfortunate consequences. Logic, being considered to be a branch of philosophy and having been treated by Aristotle, has been considered to be a subject only to be treated by those who are proficient in Greek. Mathematics, as a consequence, has only been treated by those who knew no logic. From the time of Aristotle and Euclid to the present century, this divorce has been disastrous. In addition to Dr. Hauser's paper, I also want to bring attention to a paper written by Dr. Chris Menzel. Dr. Menzel's paper is called Cantor and the Burali-Forti Paradox, which is available on his website. It also explores Cantor's mention of the Philebus. Quoting Dr. Menzel's paper, in the Philebus, Plato's use of peros and apeiron reflect their Pythagorean roots. In the well-known Gift of the Gods passage, he writes that all things that are ever said to be consist of a one and a many, and have in their nature a conjunction of limit, peros, and unlimited, apeiron. In a later passage, he reiterates this, saying that God had revealed two constituents of things, the unlimited and the limit. It is in this latter passage that ekton and its cognates appear. The passage concerns itself with the division of all that now exists in the universe into four classes. The first consists of all instances of apeiron, i.e. the various apeira in the world, and second, all instances of peros, the various parata. The third class consists of mekta, the products that result from union or a mixture of members of the first two classes, and the last contains the causes of the mixtures. But to Plato, the apeira are phenomena which can vary continuously. A phenomenon is a variable among the infinite continuum of possible values. This continuum taken as a whole is unbounded and absolutely indeterminate. The class of parata, on the other hand, are limited in how they may vary. They are discrete, but they are also determinate because they can have equality or relationships between them, like the natural numbers. So paraphrasing Dr. Menzel, the parata is associated with the class of rational numbers. Plato's third class is made up of ekta, which are mixtures of apira and paras. The classical example is that of pitch and tempo being apira, because they can have a continuous value. The 12 notes of the musical scale, seen generally, however, can be represented in terms of simple ratios between rational numbers, or as parata. These 12 notes are very special mathematical ratios of simple natural numbers. They are not arbitrary. However, a 12-note scale can be tuned arbitrarily to any base frequency. For example, in the classical world, music used to be tuned to A equals 432 Hertz, until in more recent times, the Nazi propaganda ministry, of all people, favored a tuning of A equals 440 Hertz, and the world has followed since. I have noticed a movement on YouTube to bring back the 432 Hertz, but I digress. So the 12-note scale tuned to a decided on frequency is an example of ekton. It's a mixture of apeiron and paras. This ekton and other ekton merge to form the whole art of music. Previously, infinity had been viewed as apeiron and was unknowable, but to Cantor, sets were similar to ekta. Dr. Menzel corresponds Cantor's principles of number generation with the principles of Plato's classes of being. Much like music to the Pythagoreans, representing a sort of order that tames the infinite, making it intelligible, Cantor saw his sets as being intelligible objects arising from the absolute. Rather than an indeterminate jumble of notes, Cantor's infinities were ordered sequences, like a well-ordered Beethoven sonata. But there was still one set which even Cantor could not precisely extract from the world of the apeiron, and this is the set of all sets, or the set of everything, which will remain at least mathematically indeterminate, knowable only through deeper methods of thought, perhaps. But going back to the principle of plentitude, what is possible is actual. One can assume that the so-called ontological proofs of God's existence, like those developed by Leibniz and Kurt Gödel, would have been valid to Cantor. To Cantor's way of thinking, known truths are possible only because they are consistent with God's mind, not the other way around. This is a key reversal. To Cantor, all that can exist is what is possible in the mind of God, which is 180 degrees flipped from saying God is possible because other truths exist. Cantor's approach to grasp infinity was to rethink our concept of numbers. Cantor was only able to do this because of a deeper philosophical and epistemological approach to mathematics. Cantor saw the counting numbers that we learn as children in school, 1, 2, 3, 4, etc., not only as an ordered sequence of unique objects naturally arising in our minds, but to also think of them as aggregates, or as they are called in modern times, sets, the size or cardinality of which was significant. The German word that Cantor used for set was Menge. The central notion is that a set is a collection or aggregate of members brought into a whole or unity. In addition to the members, every set has the empty set, which is a pure abstraction of this notion of unity into a whole of all of the parts, even with its members removed.